find yet another gradient of another function at some other point. I say this because I think this is the first, not the first, not the second. It's the third time I do an exercise like this. So by the time you should already know what a gradient is. It is simply a vector which includes all of the partial derivatives of the function. Precisely, it has a partial derivative for each variable, or you could say for each argument, perhaps, of this function. So in our case, we would have 3 gradients. And we would compute them ideally as follows. Start with partial x, and then you move on to partial y, then you end with partial z. Okay. What is the partial with respect to x? That's a question for you. Answer should not be too difficult. This is the function. So if we talk about the partial with respect to x, then we fix y and we fix z. Then these are just constants. And the resultant is really this coefficient, since the derivative of x is simply 1. By a similar argument, if you fix x and z, since we are taking the derivative with respect to y, then you would get x e to the y cosine of z. Because these two terms are constant with respect to y. Finally, if you want to take the derivative with respect to z, then the first term will give you the following. These are constants with respect to z. This is not. The derivative of the cosine function is not the sine function, but the negative of it. And the derivative of z with respect to z is 1. The derivative of minus 1 with respect to z is, of course, 0. So we don't need to write it down, I hope. So if that is the description of the gradient, then in principle, the gradient at 1, 0, 0 should be equal to we need to plug in the value. So e to the 0 cosine of 0, I think that's 1. Yes, it is. And then here, if you plug in 1, put e to the 0 and then cosine of 0. It's 1 for the same reason. The e to the 0 and cosine of 0 both give us 1. And finally, if you plug in minus 1 times e to the 0 times sine of 0, and sine of 0 is 0, so I don't need to write this term. I can just write 0 minus 1. That's going to give me a minus 1. Is this the correct answer? Yes, it is. And the reason for that is that you have this recording in front of you right now and you're watching it. So this is more or less a confirmation bias, really. It's less of a question that I ask to actually test if you think that's the right answer or not, and more of a question that I ask to simply to reply to it myself, I guess. It's a weird question. Maybe I should not ask this question. So when in the next question, I'll try to not ask if this is the right answer, because it's so stupid. Like if it's not the right answer, then I'll end the recording and you probably won't see it ever again, or you won't see it in the first place. But if I ask this question and then you're watching, then probably it is. Or maybe it's an incorrect answer and I'm tricking you, and so that is why you need to be always alert and ready for any mistakes that I might make. In this case, I'm glad that I have not made any mistakes. Well, I hope I haven't. Yeah, I think this is enough. We can talk about how I administer these tutorials later. I think that is enough for now.